Supplemental math videos from Circle Christian School.
Algebra 2, elimination. Elimination combination. The key step in the method of elimination is to obtain two equations in which, for one of the variables, the coefficients are opposite signs. Then by adding the two equations, you eliminate a variable and get a single variable equation to solve. Now, back substitute. Further, the dignity of science itself seems to require that every possible means be explored for the solution of a problem so elegant and so celebrated. Carl Friedrich Gauss. The method of elimination. Carl Friedrich Gauss is fairly much responsible for this method, among a few others that we're also going to investigate as to how to find x and y. You need to look or make opposite sign coefficients. The whole thing is to either get rid of the x's or get rid of the y's by making an equivalent equation. And then what you're going to do is you're going to add them together to eliminate. First thing I'm going to tell you is that you write the problem pretty much in the upper left-hand side here as you go to work. And then what you're going to do is just work off of it on the right hand side and then put your answer, your solution set, underneath it. Most of the work is going to end up on the right hand side. The more you kind of make this a habit for doing these, actually the easier it's going to help you when you have to get to the XYZ guys. Okay, as I stop to put a hat that's way too big on my grandson, and we have no idea how he can see. He just kind of walks blindly with this giant hat on his head, much like we are when we try to solve these equations. All right, so looking at this, we can see, fortunately, that we have actually opposite signs happening with the coefficients on the y's. So I'm just going to rewrite them over here. I know it seems like a super double step of redundancy here, but it really does help clean things up as you go along here. So we add the two equations together. We add the x's to the x's, the y's to the y's, and the constant numbers to the constant numbers. We get 8x equals 12. X equals 12 over the 8. Divide the 8 out of both sides, and of course we reduce it to 3 over 2. Now you back substitute into either equation here. And sometimes one looks better than another. On this particular one, there is no better. That's just the way it goes. So I'm just going with the 3 because it makes it smaller. We get the 9 over 2 plus the 2y equals 4 here. And again, we're going to just get the y by itself. Think of the 4 with a common denominator of 2. And you do your work, and y is a negative 1/4. So you have your x, you have your y, and anytime you get anything that you need, always circle it because that helps you identify it because you may need it to do something else. And then we write our solution set, again, under the original equations, which I never mess with. All right, here's another one. 4x minus 5y equals 13, 3x minus y equals 7. And you'll notice here that if we add the x's and add the y's, they don't automatically disappear. So we're going to have to make an equivalent equation. You can either work with the x's or you can work with the y's. I'm going to work with the y's. You can try it with the x's, where you would be multiplying the top one by a 3 and the bottom one by a negative 4. But I'm going to use the 5 here. Make sure you distribute it out to everybody. And it makes your equivalent equation. And you can show little arrows pointing to it. Truly, again, kind of following the way that I do it here is going to be a big help to you when you get to having to do the x, y's, and z's. So we add the 4x to the negative 15. Remember, the big number carries a sign, so it's a negative 11x. The y's say goodbye. We get a negative 22, and x equals 2. Now we're going to back substitute the 2 back inside here. And we get 8 minus the 5y. This is just super ooper duper solving for a variable. You just have to do it twice. And I'm going to minus 8 on both sides here. And we get a negative 5y equals a positive 5. So y equals a negative 1. And again, I circle any answer because you never know if you're going to use it. You can George Polya it by plugging it back in. I plug a 2 in here and I plug a negative 1 in here. Practice a little mental math. 8 plus 5, yes, 13. And I'll plug it into the other one because it has to be the same for both of them. 6 plus 1, a 7. Good to go. Let's take a look at two special cases here. The first is a no solution case. Again, we got to look and see, do we want to get rid of the x's or we want to get rid of the y's? I'm opting for the x's because it's just a smaller, least common multiple here. So I'm going to multiply by the 2 and the negative 3. The thing that you have to be careful about when you get to making these equivalent equations is just watching your math. Most of the times when you have done something wrong in these problems, it's an integer issue. You didn't multiply right, you didn't subtract or add correctly. When it's all said and done, you'll notice that the x's and the y's cancel out, gives us a 0 equals, and we just do the math here, 16 minus 21 equals a negative 5. 0 obviously doesn't equal a negative 5, so there's just no solution. They're parallel lines. They won't ever meet in space, and they'll never share a wedding cake. The next one is when we have an infinitely many case. And once we make the equivalent equations, I'm opting again here to get rid of the x's because it's just a little bit smaller. You'll see that the x's cancel out, the y's cancel out, and the 6's cancel out, and we get 0 equals 0, and we go, yes, hooray, that does make a true statement. So here, basically, x equals any number. So to go find y, what we have to do is actually plug this back into either equation, and I'm just going to go with the top one here. I'm going to put any number in here, which is an a, plus the 6y equals a 3. And the whole thing is we have to get the y by itself. So we have a 6y equals a 2a plus 3. And all I did was take the negative 2a and add it to both sides here. Now we're going to divide by a 6. And we see that y equals 1/3 a plus 1/2. So now you can kind of figure out what y is by discovering, giving yourself a value for a. And if, for instance, I made the value of a equal 3 here, then what I would have is for y, so x would equal 3, because remember, that's any number, so x equals 3. Plug it back into the other equation, and I get y equals 1 plus a half, or a 1.5. And now we can actually do the test. We can plug it back into either one of the equations here. Let me use a different color. And I put a 3 here, and I put a 1.5 here, and negative 6 plus a 6 times 1.5 is 0.39. And yeah, it does equal 3. And putting it into the other one, we get a 12 minus, let's see, 12 times 1.5 is 60. Ugh, I'm not going to be able to do that in my head. So let's just do it off to the side. Practice our mental math. Very good. 12 and a half of the 6 is what? 18. There we go. So 12 minus an 18. Yes, it does give us a negative 6. There we go. So yes, it does work. Okay, I'm going to erase those out, and I'm going to give you an application, how we can use this XY thing, another kind of mixture type of problem. This one's an application for speed. Totally these motorboat things and the planes, trains, and automobiles. But you're taking a motorboat trip on a river 18 miles upstream, 18 miles downstream. And you're running the motor at the same speed going up or down the river. But because the river has a current, it has a current speed here, the trip upstream is going to take a different time than coming back with the current. So up against the current, it's going to take you an hour and a half. And going with the current, it's only going to take you 1 hour because you've got some extra push here. We need to determine the speed of the current. The big thing here is that you have to have some really good labels. We got our boat speed. So basically, we have to find out the boat speed so we can figure out what the current speed is. Now, to be able to figure out your upstream speed and your downstream speed, we're going to have to use the distance formula. Rate times time equals distance. And since the rate or the speed of what we're trying to find here is our constant, I am just going to solve for r, which is going to give me d over t, distance over time. So the 18 is the miles, so that's your distance. And the time, I'm just going to put it into decimal. It's a little bit easier to work with here. So distance divided by the time is going to give you 12. And for the downstream speed, it's going to give you 18. Next slide. All right, so to set up the upstream, we're going to have the going upstream, we've got the boat current minus the stream current gives us the 12, and then the x plus the y equals 18 going downstream. And luckily, see, our y's are going to cancel each other out, so we get 2x equals 30, x equals 15 miles per hour, and left over, y would equal 3 miles per hour, so the stream has a current speed of 3 miles per hour. And that's how it's done in the big leagues. All right. Have a great day. Stay safe in the hurricane, and we'll see you Monday and Tuesday.